Hello U9s, sorry for the extra part, my screen capture software bugged out, so it was meant to be 2 parts, but we'll make it 3. So we've gone through these 2. Now, sketching graphs by determining x and y intercepts. We've done this a lot before, but it was a while ago, so I'll run through an example and then I'll leave one with you. So it might ask you to sketch 5x minus 4y equals 40. So one way you could sketch it is making y the subject, transposing it to have y equals blah, and then using the rise over run and the previous method. But a more robust method that works every time is finding the x and y intercepts. So you can find the x-intercept by making y equals 0. Sub that in, you get 5x minus 4 times 0 equals 40, which leaves 5x equals 40. So x equals 8. And then to find the y-intercept, you make x equals 0. So you get 5 times 0 minus 4y equals 40, minus 4y equals 40, and then y equals negative 10. So that's the x-intercept, that's the y-intercept. Then you need to sketch your graph. So none of this puny nonsense. Sketch a nice big graph. Nice and big. Show the person marking your paper what you know. Nice big graph. And it's a sketch, you want to get it about right. So if negative 10 is about there, if that's 0, negative 10, then 8's going to be about here, say. And then, once you've got your x and y intercept, rule a line through them. Whoops. I'll rub that out in a moment. Rule a line through those. And for a finishing touch, label your line equation. There we are, labeled line equation. Let's rub out that little error. So, how do you know if you're right? I don't know if I'm right, so I'm going to check on Wolfram Alpha. 5x minus 4y equals 40. What does Wolfram Alpha have to say? 5x minus 4y equals 40. Let's see. Well, let's sketch the graph. It's a line. Yes, it is a line. There we go. There we are. See that x-intercept there at 8 and the y-intercept at negative 10. It's done everything we wanted it to do. Negative 10 and 8. So you have no excuse when it comes to determining whether you've got the right answer or not when you practice, because you can use Wolfram Alpha. So I'll make up another problem. Let's have a look. This is still 1.1.3. Let's make up another one. Oh, that's not red. 1.1.3. Okay, another problem. Might look something like sketch, and this one's going to have fractions. 2y equals x on 4 minus 8 thirds. Well, same story. To find the x-intercept, make y equals 0. Now, if you're unfamiliar with this, that's okay. There will be ones where you have integer whole number answers, so you'll still be able to show what you know. But we'll try this out. So we're going to sub in y equals 0. So we have 0 equals x on 4 minus 8 thirds. Add 8 thirds to both sides. Times both sides by 4. So we get x equals 32 on 3. To find the y-intercept, we make x equals 0. 2y equals 0 on 4 minus 8 on 3. That goes away. 2y is negative 8 on 3. Divide both sides by 2. You get y equals negative 8 on 6, which simplifies to negative 4 on 3. So you have 32 on 3, 0, and 0, negative 4 on 3. Sketching this is the same as before. You've got to estimate where your intercepts are. So it's slightly trickier because you don't have whole numbers. So you have to kind of guess. So 32 on 3, it's a little bigger than 10. So you might put that there. 32 on 3, 0. Negative 4/3, that's near negative 1. So you might put that there. Grab your ruler. Make sure you have a ruler for your exam. Don't want to look like a duffer without a ruler. Make sure you bring one. Draw your line for a bit of a finishing touch. Label it with the line equation. Great. Now I can give you some problems. And I could check it with Wolfram Alpha if I was unsure. Try. This is still for 1.1.3. Oh, it's on red. Nope. Struggling here. Red. 1.1.3. Okay. Try sketching these using X and Y intercepts. It really doesn't want to change color. There we are. Sketch. Y equals 3x plus 11. You can try that and check it on Wolfram. 2y minus 16x equals 4. And try something like x plus y on 3 equals negative 12. So try those and you can check your answer on Wolfram Alpha. So no excuses for not checking your answers because computers can do that for you now. Okay, so we've got that down. This one, I'm confident everyone can get it. But it's a Year 10 skill. I mean, it's on the Year 10 course description. So you've got distinguish linear and non-linear relationships and sketch both using a range of techniques. What I'm going to give you for this, I'll be very honest here, I'm going to give you something that's non-linear, so that has like a squared. So if I give you something like, if it has a squared, and you might remember this from the practice task, if you have something with a squared or a cube, or it's probably not a line. So I want you to take something like this and tell me whether it's a line equation or not. This is what this is asking. Is this a line equation? That is my question to you. Is this a line equation? How do you find that out? Well, you draw a table of values. That's generally the way it goes. If you're given something and you're asked, is this a line equation? Rule up a table of values. Go negative 2, negative 1, 0, 1, 2, go as far as you like. Now, subbing in here. Be careful. You have negative 2 squared plus 5. That quantity becomes 4, but it's minus 4 plus 5 equals 1. Same for this one. Negative 1 squared is 1, but then it becomes minus 1 plus 5 is 4. Let's try the 0. That gives 5. Let's try the 1. That gives 4. Let's try the 2. That gives 1. Now we have to rule up a set of axes and plot all of these points to show that, and I'm going to spoil it here, it is not a linear equation. It is not. It's a parabola. It's a curve. It's not a line. Who would have thunk? Who would have thunk? Okay, you got -1, -2, 1, 2, and then you're going up to 5. So I might go 1, 2, 3, 4, 5. Let's see. We have -2, 1, -1, 4, 0, 5, 1, 4, 2, 1. Now when you join those up, it actually forms oh, that's wonky. Let's try again. Forms a parabola. So it's a curve. Is this a line equation? Well, no. No, it's a curve. No, it's not a line equation. It's a parabola. It's a curve. You will be asked a question very, very similar to this question. Okay, I have simultaneous equations here as one of the questions. Now, we touched on it last year, and some of you are up to it this year, some of you are not. If you're super, super keen, go for it. See if you can solve some simultaneous linear equations. It's for those interested or those up to it on their pathways. If you're not up to it, I'll give you a problem. So what you're looking at here is something like, and you did this on your assignments last year, those who did the extension. It's something like find the intersection between, let's say you have 2x plus y equals, let's make it 4, and y equals x plus 3. Find the intersection between these lines. So what you do is you sketch each one and you find the point where they intersect, so where they overlap. You can do that by sketching each one. You can do it with algebra. I'll show you the answer on Wolfram Alpha though. So you got 2x plus y equals 4 and y equals x plus 3. Let's have a look. 2x plus y equals 4 and y equals x plus 3. It's going to give us a bunch of things about it. Let's see what it tells us. It says, oh, it's a geometric figure, it's a point. Okay. They don't. Let's try an and. Maybe they don't tell us. And there, okay, it solves them for us. Is that what I wanted to solve? Y equals x plus 3, 2x plus y equals 4. Yes, right, okay, so this, what you're looking for by sketching it is where they intersect. So on the exam, I'm going to give you this intersection and you're going to need to try to find it by graphing both using the method I showed you before and finding the intersection. There's also an extra question there. For those of you who are up to doing that algebraically, it will go through, it'll ask you to find that solution using algebra. So I'm going to do that now. However, if you're not up to it, that's fine. But I'll show you how that works anyway. So you've got two equations. We'll call this equation 1. Call this equation 2. I would recommend to have a go at this first. So pause the video if you want to try solving this on your own. And then have a look at the solution. Did you pause it? Let's see. Well, we sub equation 2 into equation 1. So then you get 2x plus x plus 3 equals 4. 2x plus x is 3x, plus 3 equals 4, 3x equals 1, which means x equals a third. Then we sub x equals a third into the equation of your choice. Let's do number 2. And then y equals a third plus 3, which equals 10 on 3. Now that right there is the point where these two lines overlap, where they intersect. So that covers what will be on your exam, and if you have been, thank you for watching.